Hello, everyone. Let's continue with our topic groups and subgroups. Today, we will start with section 3, isomorphic binary structures. So, let's start by considering the following two tables. Okay, here, table 1 is for the binary operation asterisk on the set which elements are ABC. And table 2 is for the binary operation asterisk prime on the set which elements are the number sign, the dollar sign, and ampersand. So, okay, what we observe here, well, if we replace all occurrences of A by the number sign, and every B by the dollar sign, and every C by the ampersand, from table 1, we obtain exactly table 2. So we can write this as follows. From table 1, using the 1-to-1 correspondence, we obtain table 2. Okay? So these two tables differ only in the symbols denoting the elements of the set and in the symbols denoting the binary operations. Okay, now let's consider the following two tables, table 3 and table 4. This is for this binary operation on the set which elements are x, y, z. So what we observe here very easily. If we rewrite table 3 with elements in the order J, X, C, we obtain exactly table 4. Now observe here that we did not set up any one-to-one correspondence. We just list the elements in a different order. So now let's consider again our table 1. We can observe, what can we observe here? We can observe that if we replace all occurrences of A by J, all occurrences of B by X, and all occurrences of C by C, well, we will get exactly table 4. So we can write this as follows. From table 1, using the 1-to-1 correspondence, we obtain table 4. Okay, so for these reasons, we think of tables 1, 2, 3, and 4 as being structurally alike. Well, because these four tables differ only in the names or symbols for their elements and in the order that those elements are listed as heads in the tables. Now, however, if we now consider table 5, table 6, and again our table 1, we can observe that these tables are for these three binary operations on the same set, which elements are A, B, C. But these three tables are different from each other. So why I say that? Well, I will write this. These three tables are structurally different. Okay, why? Well, because if we observe here in the body of table 1, here appear the elements exactly 3 times. But in table 5, the body of the table contains the unique element B. Similarly, if we observe table 1, one element operated with itself will give us 3 different values, but in table 6, if we do the same, we will get a unique value, which in this case is C. So they are different. Thus, we can conclude the following. Thus, tables 1 through 6 give just 3 structurally different binary operations. Okay, so this is provided we disregard the names of the elements and the order in which they appear as heads in the table. Okay, now, what are we interested in? Well, we are interested in the different types of structures that binary operations can provide on sets having the same number of elements. So now let's give the following definition. A binary algebraic structure is a set S together with a binary operation, asterisk on S. Okay, so an important question here is the following. What would we have in order that two binary algebraic structures to be structurally alike in the sense we have described? Well, we should have a one-to-one correspondence between elements x of S and elements x prime of S prime, such that the following is true. If x corresponds to x prime and y corresponds to y prime, then x asterisk y corresponds to x prime asterisk prime y prime. Okay, very important to mention here is the following. A one-to-one correspondence exists if the set S and S prime, in this case, have the same number of elements. So what is customary? Now let's answer this question. It's customary to describe a one-to-one correspondence by giving a one-to-one function mapping S onto S prime. So in terms of the function from S onto S prime, we write this equation, C of X equal to X prime, instead of this correspondence. And also, we write phi of X asterisk Y equal to phi of X asterisk Y. Instead of the correspondence okay, so such a function showing that two algebraic systems are structurally alike is known as an isomorphism. So we have now a definition, a formal definition I have already written. So let S with asterisk and S prime with asterisk prime be binary algebraic structures. An isomorphism of S with S prime is a one-to-one function phi mapping S onto S prime such that the following property holds for every X and Y in S. Now, if such map exists, we say that S and S prime are isomorphic binary structures, and we denote this by this symbol. So, as an example, we have these two examples we have already shown in some previous videos.